Hello everyone, and welcome back. Today we're going to continue looking at Newton's laws. In particular, we're going to look at some different kinds of forces. Where are these forces coming from? And then, after that, we'll take a look at applying these forces to different objects in different situations and see what kind of responses we get from those objects. First of all, where are these forces coming from? It turns out, although you might look around and think, oh, there are millions of different kinds of forces, there are really just four fundamental forces in nature. And anything that we see are really applications of one of those four. They are the gravitational force, the electromagnetic force, the strong nuclear force, and the weak nuclear force. The gravitational force is the force that we are typically most familiar with because we experience it all the time. It's the gravitational attraction between different objects. For example, the Earth pulling on this pen downward, which creates the weight of the pen, the weight of any object. So it's a force that we are experiencing all the time. We'll look at the gravitational force in a little more detail later on. The electromagnetic force, however, is a force that we experience all the time, but we might not notice it as, or we might not know that it was the electromagnetic force. It's the force that basically acts between different kinds of charged particles, and it is really what is causing the force when you push on something. The force between your hand and the object you're pushing on is actually an electromagnetic force of repulsion that when you try to push on something, it's actually the atoms and molecules in your hand and the other object that are repelling each other that actually allows you to push on something and not just have your hand sink through something. That's the electromagnetic force. Typically, we think of gravity as being a very, very strong force. It keeps us on the Earth, it keeps the moon orbiting around the Earth orbiting around the sun. We usually think of that as a very strong force. But the electromagnetic force, in comparison to the gravitational force, is actually much, much stronger. Typically. For example, if we pick, say, two electrons, electrons are charged particles with a negative charge. We'll talk more about them later on. What we find for the electromagnetic force is that unlike charges attract, like charges repel. So if we have two charges that are the same sign, two positive, two negative, they create a repelling force on each other. They push each other apart. But if we had a plus and a minus charge, they would actually attract each other together. But if we just look at, say, two electrons, the electromagnetic force causes them to repel each other. But the gravitational force, all things attract each other due to gravity, they actually attract each other. So what's going to happen? Are they going to move apart or are they going to move toward each other? Which is stronger, the electromagnetic repulsion or the gravitational attraction? Well, it turns out the electromagnetic repulsion is much, much larger than the gravitational attraction by about a factor of 10 to the 42, which means a 1 with 42 zeros following it. That is a whole lot more zeros than that. That is extremely, extremely larger. The electromagnetic force is extremely larger than the gravitational force. The only time we really experience the gravitational force is when at least one of those objects is very, very large, like the Earth, for example. We experience our own weight due to the Earth because the Earth is so big, but you don't experience the gravitational attraction between you and some object like this pen. If I let go of this pen, it's not going to be moving towards me any amount that I could notice because the gravitational attraction is so weak between us. The strong nuclear force is a force that acts within nuclei that basically holds nuclei together. It's an attractive force between different nuclear particles that keeps it keeps protons and neutrons held together within a nucleus. Two protons are both positively charged, and we would expect the electromagnetic force to create a repulsion, which it certainly does, but if these protons get close enough together, the strong nuclear force is stronger than the electromagnetic repulsion. So if these two protons get close enough together, the strong nuclear force can kick in and hold them bound together. So it's strong because when the objects are close enough, it's stronger than the electromagnetic force. The weak nuclear force is another nuclear force that acts within nuclei that is responsible for nuclear decay or certain kinds of radioactive decay within nuclei. We say that there are these four fundamental forces, but they've had an interesting history. Many years ago, the electromagnetic force was thought to be two different forces. There was an electric force and a magnetic force. The electric force was the force that created this attraction or repulsion between charged particles. The magnetic force was the force between magnets. If you've ever played with magnets, you know that magnets can either attract each other if you have opposite poles, or they can repel each other if you have two similar poles, like a north pole and north pole of the two magnets. Kind of in a similar way to the electric force. Unlike poles attract, like poles repel. The electric force, like charges, repel, unlike charges, attract. So charges and different poles for the magnets. But primarily due to the work of James Clerk Maxwell, he showed that they were actually two aspects of the same force, what we now call the electromagnetic force. So he joined these forces together so that we can understand them now as a single force. Well, there's been some work done that have actually proposed that the electromagnetic force and the weak nuclear force are actually two aspects of the same force, what's referred to as the electroweak force. That only occurs, they seem to join together at extremely high energies, and so for our normal everyday lives, they seem to be two different forces, but according to this theory, they seem to be two aspects of the same force. There has been much work to try and join together other forces, like all three of these, into what are called grand unified theories, where all of these forces are shown to be different aspects of the same force, but under different conditions, and work to try and join the gravitational force in there as well. The gravitational force seems to be different in some respects because it seems to come about from the space-time itself. We'll talk maybe a little bit more about this later on, particularly if you take 2212. It seems to be kind of an outlier. But there is work to try and unify all of these if possible. All right, so let's take a look at some different examples of forces that we might experience. Let me just mention one thing. If you think about this force between two charged particles, say we have two negative particles that are going to repel each other. They repel each other even when they're not touching. So these two particles can be separated by a distance and push each other apart. We call this type of force a field force. And gravity is the same kind of force. The Earth attracts this pen downward even when they're not touching. They are pulled together. The force is experienced by the pen and actually the Earth. The pen is actually pulling the Earth upward as well. They feel these forces without touching each other. That kind of force is what we call a field force. The objects create a field which is experienced by the objects as a force. We'll see more about that later on. What we usually deal with in ordinary everyday life, when you push on something, we refer to those as contact forces. A contact force is a force that has to be exerted by contact between two things. I push on this wall by making contact with the wall and pushing on it. I hold up my cup here by having it resting on my hand, applying a force. I actually have to have contact with it in order to exert a force. If I let go, the cup will fall and experience a field force of gravity. So many of the forces that we'll be dealing with in this course come about actually from contact forces. But remember, where are these contact forces coming from? They're actually examples of the electromagnetic force, the force of repulsion between atoms and molecules, between the two objects that are actually making contact. All right, so let's take a look at some different forces and how they come about.